Okay guys, so welcome dito sa ating channel. Ito na yung lesson 13 ng Advanced Calculus 1, yung sequence diverging to infinity. So kung naalala nyo, ang dinidiscuss natin last time is about yung mga sequence na nagko-converge to a real number. Okay, so ngayon, ang pag-aaralan naman natin is all about sequence diverging to infinity or negative infinity. So meaning, ipoprove pa rin natin kung divergent siya sa infinity or divergent siya sa negative infinity. Yun yung mga gagawin natin dito sa video na to. So definition, so for a sequence S of n, we write the limit of S of n is equal to positive infinity provided that for each m greater than 0, there exists a number n such that n is greater than n implies S of n greater than m. Okay, similarly or likewise, we write limit of S of n is equal to negative infinity provided that for each m less than 0, there exists a number n such that n greater than capital N implies S of n is less than m. So madali yung tandaan yung definition nito. At the same time, mas madali kong nakita na mas madali siyang i-prove like dun sa convergent. Okay, so in this case, ang gagawin lang natin, S of n diverges to positive infinity. Then yung isa, S of n diverges to negative infinity. Nilagyan ko lang ng ganyan. So, ayun yung mga gagawin. So, ito yung ibig sabihin ng number 1. So, for sequence S of n, we write limit S of n, or S of n diverges to infinity, provided that ayon. Then, similarly, ito yun. Yung limit na S of n diverges to negative infinity. Similar lang sila dun. Okay, so let's have example para mas maintindihan nyo kung paano yung gagawin dito. So, medyo similar din siya. Kailangan din natin dito na parang discussion, tapos kailangan din ng formal proof o nung proving step na. Okay, so discussion muna. Siyempre, nakita mo naman dalawa yung definition. So, kung positive infinity nakikita mo, ito gagamitin natin, m greater than 0, then S of n is greater than m. Kung negative infinity nakita mo, m less than 0, then S of n less than m. Dalawa yung pagpipilian. So, example, number 1, give a formal proof that the limit of square root of S of n plus 7 is equal to positive infinity. So, let's have discussion. Okay, so for discussion, okay, so sabi dahil positive infinity, aware ka na for each m, so suppose m, or for each m na lang, for each m that is positive, kasi greater than 0, there exists n, okay, na element ng natural number, such that n is greater than big N, implies, so this implies that S of n is greater than m. So S of n is square root ng n plus 7 is greater than m. Okay, so ayan yung start ng discussion natin. So for each m greater than 0, there exists n. Yung n is dependent sa m. So meaning, hahanap tayo ng capital N, which is in terms of m. Ganun yung gagawin natin. Then such that n is greater than n implies square root of n plus 7 is greater than m. So ganun ulit, consider natin tong part na to. Suppose square root of n plus 7 is greater than m. So kung consider lalagay mo, okay lang din yun. Okay, so pag manipulate natin to, this is equal sa square root of n is greater than m minus 7. Since ang target natin is mahanap natin yung n, so take the square both side, or in evolution both side, that is n is equal to m minus 7 raised sa 2. So by the way, involution and evolution. Involution, pag ang ginagawa mo is square root, hindi ako sure kung sino yun na. Pag evolution, meaning i-square mo. Ganun yung ibig sabihin nun. So ayun yung sagot. So therefore, we can choose capital N to be m minus 7 raised sa 2. Okay, so puproceed na tayo sa ating formal proof. Okay, so formal proof. For formal proof, lagay ko na dito. Nagkakamali lagi. Formal proof. Okay, so anong gagawin? Let m greater than 0, kasi yun naman talaga yung start. Let m greater than 0. Let m greater than 0. So choose n, or let n to be m minus 7 raised sa 2, or quantity of m minus 7 raised sa 2. Then n is greater than n, or capital N, implies, start tayo dito. So n greater than n, ipapalit natin yun. So implies n greater than m minus 7 squared. Then pag ginawa natin ni square both side, or square root both side, so this is square root of n greater than m minus 7, which implies that square root of n minus 7 is greater than m. Since nabalik na tayo sa katulad dun kanina, this is plus. Okay, since nabalik na tayo dun sa kanina, so this shows, lagay ko na lang, this shows that limit ng square root of n plus 7 is equal to positive infinity. And that is done. Okay, so ganun siya kasimple pagdating dyan. Okay, sorry, hindi nakikita. Okay, so let's have number 2. Number 2, give a formal proof that the limit of n squared plus 3 over n plus 1 is equal to positive infinity. Okay, so take a look, alalahanin nyo kung naalala nyo dati sa video 12 or video 11 yata yun. May ginawa tayo doon, yung tipong yung numerator, kinuha natin yung upper bound, tapos yung denominator, kinuha yung lower bound. Okay, so ngayon, nakahanap na ako ng sagot kung lagi bang ganun yung gagawin natin. Dahil dito sa example na to. Okay, so before tayo mag-start, syempre kailangan mo natin ng discussion about dito. So discussion. Okay, so for each m, since positive infinity yan, so for each m greater than 0, okay, so there exists n element ng natural number that is dependent to m. There exists n such that n is greater than capital N, implies that the limit, or implies that s of n, which is n squared plus 3 over n plus 1 is greater than m. Okay, then we consider this thing na, so kung napansin mo, kung consider natin yan, ngayon magkakaroon ulit tayo ng parang consider si n squared plus 3 over n plus 1 greater than m. Ayun, ito yung katulad nung nakaraan, yung nangyari is bounded siya dun sa 1 over n squared. Kung napansin nyo, diba? Ang nangyari is parang 1 over n squared, yung parang n over n cube yung nangyari. So dito, kung i-check mo, yung pinaka highest na exponent niya, so lagay ko na lang, highest exponent niya is n squared over n. Okay, so yung highest exponent niya is n squared over n, which implies n. So meaning, kailangan maging bounded tong sequence na to in some constant, so parang k, so some constant times n. Ayun yung gagawin. Ngayon, ano yung pinagkaiba niya sa dati? Okay, sa dati, ito yung sa dati. Sa dati kasi, ito yung nangyari, this is n over n cube. So anong nangyari? K times 1 over n squared. Okay, so kung napansin mo, ano pinagkaiba niyan? Ito, yung n nasa denominator. So since yung n nasa denominator, ang ginawa natin, humanap tayo ng upper bound sa numerator, tapos lower bound sa denominator. Ngayon, ang gagawin natin, since yung n is nasa numerator, Okay, since siya ay whole number, ang gagawin naman natin dito, hahanap tayo ng lower bound ng numerator, then upper bound ng denominator. Yun yung pinagkaiba nila. So, let us try. So, for numerator, so we have numerator. So, what is numerator? Numerator is n squared plus 3. So, hahanap tayo ng lower bound yan. Okay, so sino yung lower? Sino yung mas mababa sa kanya? So sa akin, ang obvious kasi na mas mababa sa akin, di ba? N squared plus 3. So, feeling ko, magkakahanap ako ng lower bound niya. Mas mababa to. Si N squared. So, alam naman sir, gawin ko N squared plus 1. N squared minus 1. Okay lang naman sa N squared minus 1. Pero mas safe na yan. Tanggalin mo na yung number. At least sure ako mas mababa yan for any N na ginagamit natin. Okay, so this implies. So, next is, kailangan naman natin yung sa denominator. So, denominator. So, we have n plus 1. So, kailangan naman natin dyan is upper bound. Okay, so since upper bound yung hinahanap natin sa part na yan, pwede kong gawin is, tawag dito, diba, n plus 1. So, for n is equal to 1, that is 2. Okay, so kung naalala natin, no, we have 2n, 24n plus 3, tas for n is equal to 1, nakita ko 27. So, ginawa kong 27n. Dito naman, since nakita ko 1, for n is equal to 1, that is 2. So, pwede kong gawin, this is less than or equal sa 2n. Okay? So, meaning, anong nakita ni sir? So, we have n squared plus 3 over n plus 1, which is greater than n squared over 2n. Okay, which implies, or which is equal sa 1 over, so n over 2. So, ayan yung nahanap natin na value. So, we can choose, this is less than, so alam natin ito ay greater than m. Tama, so nakita natin na, so, we have 1/2 n is greater than m. Parehas lang yun n over 2 saka 1/2 n. So, which implies, ano yung m natin dito? So, this implies that n is greater than 2m. So, we can choose. So, we will choose n to be 2m. Okay, so tandaan yung sinabi ko about dito sa dalawang part na yan. Para makatulong din sa mga activity or mga exams natin. Lalo din sa ibang mga function din. Okay, so let's have formal proof na ito. So, the formal proof will be, okay, so let m greater than 0. Let m be greater than 0. So, we need to choose n, which is equal sa 2m. Okay, then for n greater than n implies, so ipapalit lang nato dito, so ito ay n greater than 2m. Okay, then which implies that this is 1/2 n is greater than m. Okay, so ngayon, since bumalik na tayo dito sa part na to, okay, so kung napansin mo, nakuha na natin to, meaning ito na siya, no? Since ito na siya, alam natin ito siya. So, this implies, so this shows that limit ng n squared plus 3 over n plus 1 is equal to positive infinity. So, hoping na nakatulong talaga tong part na to. Ito yung ang lumabas is k times n. So, meaning, ang kukunin sa numerator is upper bound, then lower bound, tas upper bound. Ito, upper bound, lower bound. Ayun yung pinagkaiba nila. Okay, so let's have another example. Okay guys, so hindi pala example yung sunod, theorem pala. So let's have theorem 3. So kung nagtataka saan, nasa yung theorem 1. Yung theorem 1 nasa ibang video, yung mga previous video natin or videos natin. Okay, so theorem 3. Suppose or let S sub n and T sub n be sequences such that the limit of S sub n diverges to positive infinity and the limit of T sub n is greater than 0. So it can be finite or positive infinity. Then the limit of S sub n times T sub n is equal to positive infinity. So tama yun. Napansin mo, no? Sigurado ako divergent to. So, anong nangyari? So, yung limit ng t sub n is greater than 0. So, kunyari, number siya, 4 or positive infinity. Ngayon, ang sabi niya, yung product ng limit na yun is equal to infinity. Ngayon, ito yung concern. So, pagdating sa discussion, paano siya ipoprove? So, ito yung proof. Okay, so by the way, start tayo sa discussion. So, for discussion niya, okay, so aware tayo na magle-let tayo ng m. Let m greater than 0. Then we need to show, that the limit, yung limit ng s sub n, t sub n is greater, para mag-exist yung limit ng s sub n, t sub n is equal to infinity, dapat ganito mangyari. We need to show that s sub n, t sub n is greater than m. So, hindi ko na sinunod yung iba. Ang goal ko kasi ito eh. Okay, yan yung concern ko. Pero may mga may meron kasi tayo mga parang pwedeng magamit sa loob. So, unahin ko lang muna yung limit ng t sub n greater than 0. So, dalawang klase kasi yung pwedeng mangyari dyan. It's either finite siya or positive infinity. So, we have limit. Ito una, we have limit ng t sub n is greater than 0. So, this implies, okay, so since yung limit ng t sub n is greater than 0, alam ko may number yan. So, kunwari, may positive number na mag-i-exist yan. So, suppose na m siya. So, there exists m such that, ito yung nangyari, si m less than dun sa limit ng t sub n. Okay? Which is greater than 0. Tama naman. So, ulitin ko lang ha. Ang ibig sabihin ka ng limit ng t sub n greater than 0. So, meaning, hindi natin sure kung finite siya. Kaya nga nilagay ko is m. So, hindi ko sure kung finite siya or infinity. So, meaning, pwedeng real siya or positive infinity. Ayun lang yung ibig sabihin ko dyan. Pero, ang sure ko, greater than 0 siya. Okay, ngayon, mula dito, sa limit ng t sub n is greater than m, this implies or observe, so, it is clearly na yung t sub n is greater than m. So, meron akong t sub n. Ang problema natin, yung limit ng s sub n. Kasi wala talaga tayong formal definition ng limit ng s sub n. Okay, so para mag-exist yung limit ng s sub n is equal to infinity, kailangan natin gamitin to. S sub n, t sub n is greater than m. So, consider latency s sub n, t sub n is greater than m. So, since aware kasi t sub n is greater than 0 kasi m siya, kasi alam natin yon, pwede ko siya divide both side by t sub n. So, this is s sub n is greater than m over t sub n. Since yung t sub n is m, pwede natin palitan. Therefore, s sub n is greater than m over m. So, meaning, nakahanap tayo ng dalawang value ng t sub n. Sa t sub n, ito yung value na. Sa n sub n, ito yung value. Yan yung mga gagamitin natin mamaya sa formal proof. So, ito yung ating formal proof. So, for formal proof, so, ano ba kailangan hanapin natin sa formal proof? Una, dalawa. Dalawa yan. Bakit siya dalawa? Una, yung limit ng t sub n. Okay? Pangalawa, yung limit ng s sub n. Kailangan natin magamit yung mga yan, yung mga binigay ko dyan. So, let m greater than 0. Okay? So, since 0 is less than m, less than t sub n, okay? Ito yung dalawang klase. Whether yung limit ng t sub n is equal to positive infinity or not. Okay? Sure pa rin ako na may mag-i-exist na n dyan. Pero hindi ko gagamitin n. Gagamit ako n sub 1 such that n is greater than n sub 1 implies, ano ibig sabihin na implies yan? Implies that t sub n is greater than m. So, definition lang ng divergent sequence. O positive definition lang ng sequence diverging to positive infinity. Ay lang nangyari. Ngayon, another likewise. So, likewise, yung limit ng s sub n is equal to positive infinity. So, para mag-exist yan, by definition ng divergent to sequence, nung definition natin, there exists N2. Okay, so there exists N2 such that N is greater than N sub 1 implies si S sub N is greater than M over small m. Kasi ito yung ginamit natin kanina. Okay, so yan, dalawang yan yung gagawin natin. So we will choose N to be the maximum between N1 and N2. Okay, so after mo ma-choose yan between maximum ng N1 and N2, anong pwede natin gamitin? Then, yung definition for N greater than capital N, kasi ito na yung mismong definition, implies, ano yung value nun? S sub N times T sub N, no? So, we have implies that S sub N, T sub N, T sub N is greater than, ano yung S sub N? S sub N is M over M multiplied by M, which is equal sa M. So clearly, yung limit ng S sub N, T sub N, yung limit ng S sub N, T sub N is greater than M. Kasi yun naman yung definition eh. Kung napansin nyo sa definition, ang goal lang naman na talaga natin is mapakita na yung limit nung hinahanap natin is greater than M, para masabi natin na divergence sa positive infinity. So nakuha ko na yung limit niya is ganun. So implies that S sub N, T sub N greater than, substitute ko lang yung M times M over small m times small m is equal to M, kasi makakancel lang yan. Therefore, this is done, or the limit ng S sub N, T sub N is equal to 0. Ganun kasimple yan. Okay, so now we need to use this theorem in order to prove ito. So meaning apply lang natin tong nagamit natin na yan para at least magawa natin to. So ano kailangan natin dyan? Ang kailangan lang natin is makahanap tayo ng S sub N sa T sub N, where yung S sub N is infinity, yung isa naman is finite or infinity. Then yung product nila is equal to positive infinity. Ganun na yung gagawin natin dito sa example na to. So use theorem 3 to prove that limit ng n squared plus 3 over n plus 1 is equal to infinity. Okay, so let's try, no? Ito yung proof. So observe muna natin. Observe that yung n squared plus 3 over n plus 1 ay, di ba, ganito ginagawa natin pag infinity dati sa may function. Dinidivide natin sa highest, kunyari, x squared plus x cube. I-divide natin lahat ng term sa x squared sa x cube. So dito, i-divide natin lahat ng term sa n squared. Okay, so divide lahat ng term sa n squared. So this is 1. No, so this is 1 plus 3 over n squared all over. This is 1 plus 1 over n. Okay, so in that case, dalawa yan. Parang dalawa, sir. This is 1 plus 3 over n squared. Ito yung isa. Multiplied by 1 all over 1 plus 1 over n. Okay, dalawang klase yan. So let me call this, ito yung S sub N. So let me call this, ito yung S sub N. Ito yung T sub N. Okay, so check natin ha. What is the limit? So now the limit ng S sub N natin, which is equal sa limit ng 1 plus 3 over n squared. So what is the limit niyan, sir? Observe na yung limit niya is equal to, habang lumalaki itong number na to, imagine mo, habang lumalaki yung number na to, kinapansin ka lang ha, wait, dinivide ko siya lahat sa n squared. Okay, may mali pala ako nakita dun. So ito gagawin ko ha, ang gagawin ko, i-divide ko na lang lahat sa n, kasi ang nangyari naman dito, parang dinivide ko rin naman talaga totally sa n yung ilalim na ito eh. Okay, so anong nangyari, diba, n squared plus 3. Ang gagawin ko na lang, i-divide ko na lang yung buong equation dun sa may smallest na exponent niya. So sir, bakit sir? Gusto ko kasi ipakita na yung limit ng S7 is infinity. Tapos yung limit na ito nag-exist. Tapos para ma-apply natin yung theorem. Okay, so in this case, gagawin ko lang tong n. Tapos gagawin ko tong n. Ayun lang naman yung mali doon. So ito ay n. Ito ay n. So therefore ito ay n. Ito ay n lang. Ayun lang yung mali niyan. So obviously, as n approaches infinity, this is equal to positive infinity. So meaning nakuha kay S7 na positive infinity kasi gusto ko nga i-apply yung theorem sa taas. Next is yung limit naman. So let us take the limit ng 1 over 1 plus 1 over n. So obviously ito ay equal sa positive 1. No, as n approaches infinity, that is equal sa positive 1. Okay, so ngayon by theorem 3, since nakita ka, no, since the limit of S sub n is positive infinity, the limit of t sub n is greater than 0, which is 1. So therefore, by theorem 3, yung limit ng n squared plus 3 over n plus 1 is equal to positive infinity multiplied by positive 1, which is equal to positive infinity. And that is done. Okay, so ulit ha, dumiskarte lang ko para magawa. Kasi kanina napansin ko, kung dinivide ko by n squared, 1 and 1 yan. So nag-exist yung limit, wherein hindi natin kayang gawin. Okay, so ayun yung technique sa mga ganitong bagay. So now let's have theorem 4. For a sequence of S sub n of positive real numbers, we have limit na S sub n is equal to positive infinity if and only if the limit ng 1 over S sub n is equal to 0. So kung napansin mo yung word na if and only if, una, assume natin na yung limit na S sub n is infinity, prove natin na ganyan. Pangalawa, assume natin na yung limit na ito is ng 1 over S sub n 0, then show natin na yung limit niya is infinity. Ganun kasimple. So ulitin ka lang, this is theorem 4. So, ita-try natin i-prove. So, ang gagawin ko, ipoprove ko lang yung case ng papunta. Then, yung case ng pabalik, which is yung converse, is mag-serve as problem set or magiging part ng problem set number 4 nyo. Okay, so let's have proof na ito. So, ulitin ko lang, ang ipoprove ko is yung case 1 lang. So, yung case 2 will serve as your problem set or exercise. So suppose, so we all know that the limit of S sub n is equal to infinity. So since yung limit ng S sub n is equal to positive infinity, so by definition of divergent sequence, okay, so by definition ng divergence to positive infinity, there exists m, or for all m greater than 0, for all m greater than 0, there exists n such that n is greater than capital N, implies S sub n is greater than m. Ngayon, ang goal ko kasi, kailangan ko maging 1 over S sub n. Okay, so yun ang goal ko. Ngayon, mag-set ako. Ngayon, dito malalaman mo mamaya. So, set m to be 1 over epsilon. So, mamaya may kita mo bakit ginawa na sir yan. So, ang mangyari, since m is 1 over epsilon, this implies that S sub n is greater than 1 over epsilon. Okay, then pag minanipulate natin yung part na yan, so this implies that epsilon is greater than 1 over S sub n. So, kung napansin mo, ito na yung definition nun. Okay, so, for every epsilon greater than 0, there exists n such that n is greater than capital N, implies yung 1 over S sub n minus 0 is less than epsilon. Kasi pag pinrove yun, ito kakalabasan yun eh. Okay? This shows that the limit ng 1 over S sub n is equal to 0. And that is done. So, mapapansin mo sa case 2, anong gagawin mo? Dito ka mag-i-start. So, probably, mahanap mo dun na epsilon is 1 over epsilon. Okay, then, babalik mo lang yan. So, ayun yung magiging technique nyo para gawin yung case 2 yan. Lalo kung ilalagay ko siya sa problem set. So, let's have proposition. The proposition is all about sandwich theorem or squeeze theorem. So since proposition siya, so required ako na i-prove talaga siya. So pag nabasa mo yun, lalo pag mga discussion, pag sinabi proposition, more likely dapat ipoprove siya. Pag theorem, may theorem na i-skip, may theorem na hindi ipoprove. Mga ganun yung gagawin. Okay, so ito yung sandwich theorem for sequences. Iba, almost parehas lang din siya dun sa sandwich theorem ng function, pero pinagkaiba dito, yung mga iniipit is yung mga sequence. Okay, so let us A sub n, B sub n, C sub n be sequences of reals, and let's see element na real number. Suppose that A sub n is less than or equal to C sub n is less than or equal to B sub n for all n, and that the limit of A sub n approaches to C and the limit of B sub n approaches to C, then C sub n converges and the limit of C sub n is equal to C. So ang goal lang natin, kailangan mapakita natin na yung limit ng C sub n converges, so meaning dapat may lalabas na value, then yung limit ng C sub n is equal to C. So una dapat nag-exist, pangalawa dapat yung limit niya is C. Okay, so we have two assumption or parang hypothesis dito. Ito yung proof. Okay, so una, suppose we have A sub n. So A sub n approaches to C. So this implies by definition of convergence, for every epsilon greater than 0, there exists n sub 1 such that n is greater than n sub 1 implies yung A sub n minus C is less than epsilon. Okay, next is yung B sub n. B sub n. So B sub n approaches to C. This implies that for every epsilon greater than 0, there exists n2 such that n is greater than n sub 2 implies the absolute distance ng B sub n minus C is less than epsilon. So wala na akong pakialam dun sa tawag dito, yung epsilon over 2, hindi ko nun yung gagawin ko. Okay, so ngayon, i-consider ko tong part na to sa itong part na to. So consider natin si A sub n minus C less than epsilon. So ito yung una, i-read ko na lang. Okay, si A sub n, so absolute value ng A sub n minus C is less than epsilon. By definition of absolute value, okay, so by definition of absolute value, that is negative epsilon is less than A sub n minus C less than epsilon. Okay, then add lang ako both side ng C. This implies that C minus epsilon is less than A sub n less than C plus epsilon. So ayan yung una. Next is kunin natin yung B sub n. Yung B sub n minus C is less than epsilon. So similar yung mangyayari. So that is negative epsilon less than B sub n minus C less than epsilon. This implies that C minus epsilon less than B sub n less than C plus epsilon. Okay, ngayon, napansin nyo, suppose that A sub n is less than or equal to C sub n less than or equal to B sub n. So meaning, pag ginamit ko yung property na yun, so since, ito na lang no, since A sub n is less than or equal to C sub n less than or equal to B sub n, pwede kong i-assume, di ba, anong nangyari? Sa A sub n less than sa C minus epsilon, greater than, then less than siya sa C plus epsilon. Tapos anong nangyari? Ayun siya. Tapos, si B sub n ganun din. Okay? So meaning, si B sub n less than din dun sa part na yun. Ibig sabihin, si C sub n, this implies that C minus epsilon is less than C sub n less than C plus epsilon, which implies that negative epsilon is less than C sub n minus C less than epsilon. Okay? So ngayon, dahil dalawa yung n, choose lang natin. Hindi ko kasi pwede agad dyan. Choose n to be the maximum between n sub 1 and n sub 2. So, for n is greater than n, we have, gamitin natin to, implies, itong part na to, yung absolute distance ng C sub n minus C is less than epsilon. Okay, so therefore, C sub n converges. So, the limit, or therefore, the limit ng C sub n is equal to C. Kasi alam ko ng convergence. So, anong nangyari, sir? Bakit ka nag-choose? Kasi hindi ko pwede right away na balik dito nang hindi pa ako pumipili ng aking n para dun sa aking C. So, therefore, ganyan i-prove si squeeze theorem. So, pag nagkaroon ako ng time, mahanap ako nung parang illustration ng squeeze theorem na yan. Kasi hindi ko rin ma-imagine talaga paano ko i-illustrate yan. Kasi mga sequences yan eh. So, yung sequences, hindi natin alam yung behavior o yung drawing. Hindi naman siya graph. Okay, so siya ay usually mga dot something. So, hindi natin alam kung ano yung itsura niya, prof. More likely. So, pag nakahanap ako, magbibigay ako ng video para natin, or maglalaan ako ng isang video or discussion about dun. Okay, so let's have application na itong squeeze theorem. Try natin i-apply. Okay, so application, let A element ng real number such that yung absolute value of A is less than 1, then the limit ng A sub n is equal to 0. So, kung napansin mo, nasa theorem yata to last time sa mga huling video natin. Okay, so, ang gagawin natin, ipoprove natin siya. Okay, so, ano unang gagawin natin? Yan ang concern, if A is less than 1, ngayon lang ang gagawin ko, ito yung proof. So, diba, absolute value of A is less than 1. So, ito, if A is not equal to 0, so, pwedeng mangyari na yung 1 over A is greater than 1. Okay, diba, ito, yung absolute value ng A less than 1, pwedeng ganito mangyari. Yung 1 over absolute value of A is greater than 1. Binaliktad ko lang inequality. Okay, pag binaliktad ko, magbabaliktad yan. No? So, 1 over 1 pa rin isa, kaya 1 pa rin yung ganyan nangyari. Okay, so ngayon, pwede natin siya i-represent into ganito. Diba? Si 1 over A. Because ewan ko na-discuss to sa calculus 3 nyo. So, yung 1 over absolute value of A, pwede natin sabihin na siya ay something na 1 plus H. For some H greater than 0. And ano ibig sabihin yan, sir? That is, kunyari, yung A mo, di ba? Yung A is less than 1. So, yung A, kunyari, nag-divide ka ng something na number dyan. Napin yung calcu. Yung A ko is less than 1 lagi eh. So, kunyari, nag-divide ako ng 1 over, check ko lang sa value. Okay, so, kunyari, 1 over 0.005. Kasi less than 1 eh. So, pasok naman lagi yan. So, napansin mo 200. So, napansin mo 1 plus something yan. So, 1 plus 99. Ganun yung nangyayari. So, sure ako lagi na may 1 plus H. Yung H na yan is greater than 0. So, depende yan dun sa nagiging value ng A. Ganun yung mga example yan. So, ngayon, napansin mo, para siyang binomial theorem. So, ang goal kasi natin, dapat makuha natin limit ng A sub n. Gamit to. Okay, so pag ni-raise ko yan both side by n, so meaning ginagawin ko, i-involution ko or evolution ko, no? So, that is 1 over A raised to n. Kasi wala naman magiging epekto. So, this is equal sa 1 plus H raised to n. So, kung napansin mo, binomial na siya. So, by binomial theorem, ano ibig sabihin nun? By binomial theorem, ano ibig sabihin nito? Sir, ito po ay ibig sabihin nito is 1 plus nh plus, kasi ito yung n taken 0. N taken 0 tapos H. N taken 0, H, so N, so plus N taken 1, so ito yung N taken 1, tapos H squared, plus N taken 2, H cube, plus that plus, that is H raised to N. By binomial theorem, kung naalala mo. Ngayon, kung kukunin ko yung upper bound, nung part na to, yung lower bound, yung kanyang lower bound, lower bound, ang lower bound dyan is ito, is less than or equal sa 1 plus nh. Ngayon, pag kinuha ko yung supremum, this is less than nh. Ngayon, ang concern ko lang naman lower bound. Okay, ito lang naman yung gagamitin ko. So, ngayon, ibig sabihin, itong 1 over a raised to n, na kaya pansinin niya, di ba? So, meron tayo na form na ganito. 1 over a raised to n is greater than or equal sa 1 plus nh, which is greater than 0. Alam ko kasi greater than 0 yan. Ngayon, pag ni-reverse ko yung process niyan, so, pag pinlip ko yung inequality, so magiging less than. So, ito magiging absolute value ng, so ito yung 0, mauna ito, no? So, 0 less than, ano yung magiging value ng isa? Less than 1 over 1 plus nh. Less than or equal sa 1 sa absolute value ng a raised to n. Okay? So kung napapansin mo, ito na yung value na kailangan natin. Okay, so by squeeze theorem, may limit kasi ako nito. So aware ako na may limit tong part na to. Okay, sorry, magbabaliktad. Ang napansin ko, no, pag nag-flip, baliktad pala, no, pag nag-flip, sure ako yung 0 pinakamaliit. Pero ito sa dalawang to, ito na yung mas maliit. Okay, baliktad pala sa 0. So dapat ito ay, sorry. So dapat ito ay 0 less than or equal sa absolute value na a sub n less than or equal sa 1 over 1 plus nh. Pag nag-flip, pag nagpalit ako ng inequality. Okay, so pag nag-revert na ganyan. So anong nangyari? By sandwich theorem, so alam mo to, approaches sa 0. Okay, aware ka rin approaches sa 0 to. As n approaches infinity. Okay, kasi as n approaches infinity, lalaki lang naman to. So 1 over 1 plus infinity, kahit h pa yan, lagi yan 0. So by sandwich theorem, the limit ng absolute value ng a sub n is equal to 0, and that is done. Okay, so ito yung usual magagamit natin. So kunyari nakita ka ng ganyan, pwede ko express as ganyan. Ngayon pag nakita ka ng binomial theorem 1 plus h raised to n, ito yung kanyang lower bound, tapos ito yung kanyang parang supremum. Pwedeng gawin niya. At sure ako laging greater than 0 yung mga ganyang bagay. Okay, ganyan yung magiging application natin. So that's all for this video. So sa next video is about monotone sequence. Naka-ready na dyan, nakikita nyo. So hoping na sumusunod ka pa rin sa video natin.